Now, what do we mean by a buffer? A buffer, by definition, is a solution that resists a change in pH when acid or base is added. Now, I'd like you to recall from the overhead that I showed you, this one, that we could add, or for that matter, subtract a whole lot of base. And look how flat this pH curve is right around the pKa. Once I get far away from the pKa, like a pH of around 3 or a pH of around 6, if I start adding or subtracting a little bit of base, look how much I change my pH. But right around the pKa, if I add or subtract some base, doesn't really make a whole heck of a lot of difference, does it? And so the principle behind a buffer is to make something that's going to work close to the pKa of the molecule that you're using as the buffer. So how do we do it? Let's make a buffer. Okay? So to make a buffer, we're going to add two things together. We mix together a weak acid and the salt of a weak acid. As an example of this, let's make a solution of 10 millimolar acetic acid. Example, 10 millimolar acetate or acetic acid buffer. Okay? Sorry, I'm going to make it 20 millimolar. Okay? So we're going to use 1 liter of H2O as our final volume, and we will dissolve in it 0.01 molar. We will make it 0.01 molar acetic acid and 0.01 molar sodium acetate. Okay? Now, when I do that, and this is an example, this is an important, right? This is an important point. This is an example of what we're going to call a closed buffer system. Well, now you know how much acid, you know exactly how many moles I have, because if it's 0.01 molar and it's in a liter, that must mean that I have 10 millimoles total of acetic acid, and I have 10 millimoles of acetate anion. Okay? Now, let's add a strong acid to this. And you know what the pH is, right? The pH for this solution that we just made up, if I make it this way, the pH is equal to the pKa 4.76 plus the logarithm of the two concentrations, 0.01 molar divided by 0.01 molar, and that's 4.76, right? Because this is 0. Now, let's do an experiment. Let's add 1 millimole of hydrochloric acid, a strong acid, to this solution. Okay? And we're going to try two things. We're going to add it to either 1 liter of pure water or 1 liter of our 20 millimolar acetate buffer. If we add it to pure water, our starting pH was 7. If I add 1 millimole of hydrochloric acid, that's 0.001 moles, what's our pH going to be? How many people think it's going to, I'm going to give you 3 choices. It's either 9, 5, or 3. Okay? How many people think it's 5? How many people think it's 9? How many people think it's 3? Sure, the pH went from 7 to 3. So we had a change in pH of 4 units. let's do the same thing, the exact same thing in our buffer. Okay? Now remember, our buffer started with a pH of 4.76. Okay? Now, what happens after we add 0.001 moles of hydrochloric acid? Well, of course, it completely dissociates. It's a strong acid, right? And so what's going to happen? This is going to give rise to 0.001 moles of protons. And what are those protons going to do? Well, they're going to react very strongly with the acetate anion, aren't they, right? And as a result, what's going to happen is the acetate anion, which used to be CH3COO minus, right? That concentration used to be 0.01 moles, right? We said it was 10 millimoles, right? And this now is we're going to have to add to this 0.001 moles. Sorry. Yes. Sorry, I apologize. This acetate anion is going to be consumed by that proton. So we're going to lose 0.001 moles of that because that's going to react with this proton. So our final concentration of acetate anion is going to now be 0.009 molar. Okay? The acetic acid that we started with was 0.01 moles. Okay? And that increased now by the amount with which this proton reacted with the acetic acid. So this now gained 1 millimole to become 0.011 molar. Okay? So what's our new pH? Well, our pH is just equal to 4.76 plus the logarithm of the new concentration of acetate anion, that's 0.009, divided by the new concentration of our acetic acid, which is 0.011. And this number, if you calculate the logarithm of this works out to be 0.09. Okay? And so, sorry, it becomes minus 0.09. And so our new pH is 4.76 minus 0.09, or 4.67. So what happened? Our buffer started out at 4.76, and it ended up at 4.67. We had a change in pH of 0.09, minus 0.09. Look at the difference. In water alone, we had a change in pH of 4 pH units. In the buffer, we had a change in pH of 0.09 pH units. Okay? The buffer consumed the protons and changed its pH only a little bit.